This is the April 2022 Phoenix LiDAR Systems webinar. Our host this month is Corey Kellum, who is one of our geomatics engineers here at Phoenix and has also transitioned over to the sales team. So Corey, why don't you go ahead and get started and take it away.
All right. Thank you so much, Lito. All right, here we are. So before we jump into the webinar, I'd like to give you all just an overview of what Phoenix LiDAR Systems does and who we are. So we specialize in compact, customizable survey-grade mapping systems. And they can be mounted to they can adapt to a variety of different platforms, from UAVs to cars to backpacks. And today we'll be focusing on the helicopter side of things. In addition to hardware, we also offer a variety of robust software packages to help you anywhere from mission planning all the way through to collecting data and producing paid deliverable data products. And it's worth mentioning, we were the first company to produce a commercial UAV LiDAR system. And we've been doing this for quite some time now. And actually this year will be our 10-year anniversary. While we created the first commercial UAV LiDAR system, there were a couple other things that were not in place. So we needed to create those as well, like first real-time 3D point cloud visualization software, and also the first UAV LiDAR terrain following flight planner. And then later on, we went to also develop the first cloud-based LiDAR post-processing platform. And in a nutshell, if you have a surveying challenge, we have a surveying solution to fit your budget, your accuracy needs, and just your overall capability for your project. So I'm excited for today's webinar. We will be discussing the Ranger series and how it's a revolution in helicopter LiDAR solutions. I will be your host, Corey Kellum, and I'm the senior sales engineer, as Lito mentioned. And with me, we have our special guest, Eric Getch. He is the Vice President of Helicopter Operations and R&D. And yeah, welcome, Eric. Thank you for joining us today.
Yeah, thanks for having me. Looking forward to doing this.
Yeah, appreciate it, man. So before we get into the discussion, I'd just like to go over a quick outline. So first, Eric will give us a rundown, introduction of what SkySkopes does and the value, how they utilize our systems and they benefit from it. Then we'll have a discussion and we'll go into detail about the various systems that SkySkopes is using on different platforms, and specifically the helicopter platform, and what kind of applications they're using LiDAR for, and how they benefit from LiDAR. We'll save some time at the end for a question and answer portion. So if you're listening along and you have any questions for either Eric or I, please feel free to just type that into your questions into the chat, and we'll end on some closing remarks. So Eric, I'd like to hand it off to you, and I'm just curious that what does SkySkopes do? And can you just give us a general overview of your company and also what you do for SkySkopes?
Yeah, thanks, Corey. I'll kind of talk about SkySkopes here and who we are. So we started out in 2014 out of Grand Forks, North Dakota. And we really grew from kind of 8 core people to just one office in Grand Forks to now over 50 employees operating across the nation with 6 different office locations. And really who we are, we specialize in really 2 main areas. The first one being data collection. So we really specialize in, data collection being platform agnostic. So started off as a drone service provider, and now we operate a wide variety of platforms to really kind of figure out what the best platform is for each individual project. And then we also offer geospatial services. So aside from just collecting the data, we have a whole team of dedicated LiDAR processors in-house, and as well as a GIS team that is really experts in creating our own GIS services or assisting other clients with GIS services. So that kind of sums up SkySkopes. I've been with SkySkopes for just over 5 years now, and started off doing a lot of drone flying, drone collection, LiDAR acquisition. About a few years ago, we kind of started getting into the LiDAR side of things, and kind of slowly transitioned into some small helicopter projects. And it kind of just grew into where I am now, where I lead the helicopter operations side of things, as well as the research and development team.
Very cool. Which states do you work out of? So you have 6 offices.
Yeah, so we have offices in Minnesota, North Dakota, Arizona, Texas, and California.
And can you guys handle jobs within any state? Are you able to be deployed to any state?
Yeah, we do projects all over the place. Majority of our work is in California and that West Coast region, but we do projects all over the country. So we're very used to traveling.
Great. So let's get into your LiDAR systems. And I know that you have a number of Phoenix LiDAR systems. Can you start by telling us which LiDAR systems that you use and on which platforms?
Yeah, so I'll start off with the ones we've had the longest. The Ranger LR we use, that we can use on both a drone and a helicopter. Ranger UAV, that's strictly drone. Typically, we've been using the M600 as well as the Watts Prism. A Recon A, which is for an M300, and a Ranger XL, which we utilize on our Rotorcraft.
And so you started on a UAV with is that a Scout 32 system? Then you moved on to the Ranger series?
Yeah, exactly. So that picture on the left there, that's our very first LiDAR system that we acquired on a M600, and that's the Alpha AL332.
Was that 6 years ago?
That was not quite 6 years ago. I would say 2017. So like 4 to 5 years ago is when we first got that.
Yeah, you guys have been at this for a while. And what did SkySkopes do before investing in a Phoenix LiDAR system? Like how's your workflow changed, or like the data products that you deliver to your customers since you've had the Phoenix LiDAR system quiver?
Yeah, so we started off as a drone service provider solely, kind of started right at the beginning of the industry. So I'm sure as a lot of people on here know that just a lot of different use cases and applications that were kind of started and just feeling out what data products drones are actually good at providing. So a lot of the work that we did for engineering firms before the LiDAR system was strictly orthomosaics and photogrammetry type work. And when we added our LiDAR system, it really added a lot of legitimacy. But even at the very infancy of the LiDAR space for the drones, a lot of engineering firms didn't quite grab onto it right away, just because it was such a new technology. And it's cool to see now where a lot of these engineering firms, see the value, and it's proved out that, yeah, we can go buy one of these systems and drones and collect some of these smaller projects. So it's kind of cool to see that natural progression of the industry. And then that's really what has allowed us as a company to progress from doing the smaller, 10, 20, 30 acre projects with a drone to where we are now, where that transition really was utilizing, like in the middle picture here, it's an R44. This we just rented out with a helicopter service provider, put our Ranger LR system onto it, and did a 96 square mile project with it. So that's kind of the transition, as we started using our same sensors we can use on the drones on Rotorcraft, and just saw the value of that and started winning more and more projects. And that kind of has led to where we are now, where we operate a handful of Rotorcrafts across the country.
And with the flexibility of your Ranger LR setup, for example, would you say, would you recommend a person that's getting into this space to start with UAV applications and then build your way up to a helicopter? Or what would be your advice to them?
Yeah, My advice would be, it's a relatively straightforward process as far as going out and collecting data. But it's always a smart idea to start small, build up your company's portfolio, your experience and resume. It's going to be hard for a company just getting into the LiDAR space to, bid on a huge survey project when they don't have any experience. But also to be able to just kind of work out the kinks, make some mistakes on smaller projects before you start, spending over $1,000 an hour for a rotorcraft to be up in the air collecting. It's just the stakes are a lot higher and a lot more kind of upfront costs that you can't really make those mistakes.
Right. Yeah, this could be costly. And that's kind of the beauty of the Ranger system, right? Being able to start with a UAV and use the same sensor, the same payload on a rotorcraft.
Yeah, exactly. Yeah, very versatile in what it can do as far as the operating altitudes and speeds. So very useful.
And obviously you have quite a number of systems. Is there any new system that you would be interested in adding to your quiver? Any new technology out there?
Yeah, we've been kind of eyeing up the Ranger Ultra. We do a lot of corridor type collections, and getting that dual field of view to just get more angles on, let's say, a lattice structure power line, and also that wider field of view. Typically when we're doing power line inspection work with our gimbal, which we'll talk about later here, we're flying at lower altitudes, so just getting a wider swath, which that Ranger Ultra has, is also something that we're interested in as well. So always trying to stay on the cutting edge, and with so we're really trying to keep up with that, and we kind of pride ourselves on using the best and most cutting edge sensors.
Well, you're definitely doing a good job of that. So yeah, let's kind of get into your sensor technology and talk about how, I'd like to ask you, how does SkySkopes best leverage Phoenix LiDAR Systems technology in this helicopter mapping space?
Yeah, I think our bread and butter for the rotorcraft side of things is in the electric utility space. Helicopters are just the right platform for that kind of survey when you're flying lower, slower, and trying to follow a zigzagging power line. But with that, we're able to offer a consolidated type approach where we're not just collecting a LiDAR data set. We're able to collect with our camera gimbal that we have on the front, as well as our LiDAR system. We're able to collect quite a bit of data. So really in one flight, we're able to collect 100 megapixel oblique imagery of poles, thermal imagery, corona, 4K video, LiDAR, 4-band ortho, and then RGB ortho all in one flight. So typically that would be done in 2 to maybe 3 different type of collections, so where we're able to go up one time, collect all of these data sets that can be used in a multiple departments or areas in an electric utility company.
And that's kind of like the holy grail for utility line inspection, right? Doing everything in one flight as opposed to 3 flights.
Exactly. Yeah. Not only are you saving money, but you're also, it's just less of a nuisance to customers, if you're only flying it once. And then obviously just the safety factor, you're only flying it one time, but also the safety factor of being able to fly higher is very important for safety. So utilizing that Ranger XL, we're able to fly at 800 feet if we need to, and still get good conductor and static wire returns, which are really important for like the vegetation management and engineering side of things.
Yeah, and I think we have a video here. I'll get it playing. It's a series of screenshots of cross sections cutting through a corridor. Yeah.
So I'll kind of talk about the benefits that we've seen of our Ranger XL system, and also just helicopter-based LiDAR. So compared to fixed wing, which is what a lot of larger survey firms utilize to do wide area mapping, which is great for wide area mapping. I mean, airplanes are great for flying long distances at long times at a relatively low cost. Where rotorcraft really shine are, like I kind of talked about, are flying on the power lines where you're 300 to 500 feet AGL flying at 50 knots. That's just not a good, safe profile for an airplane, to where helicopters allow you to do that, all while making, tight turns to be able to follow the power line. So with that, flying lower and slower, we get better canopy penetration, more accurate ground modeling. And all of that is really important kind of on the post-processing and data deliverable side of things, where having that high point density allows for not only the engineers to look at the power line and use that data, but also the vegetation management crew and whatnot. There's just a lot more use cases for that point cloud than collecting, let's say, just a low resolution point cloud for strictly vegetation management. They might not be able to use that for an engineering type survey.
Right.
Yeah, so and then there's a chart here that kind of shows how the point density changes with altitude. And our typical flight parameters when we're collecting power lines is around that 500 feet and 50 knots. And you can kind of see the specs that we're able to get with this XL system.
Yeah, that's fantastic. Would you say like does your team find it easier to process a helicopter data set of say like a corridor transmission line versus like a single helicopter data set versus multiple UAV data sets and combine them?
Yeah, I've talked to our geospatial team about this. I remember one project that we did back in the day. It was 40 miles of power line that we used a drone for. And that took us, it was like 3 or 4 days. And we did about 10 separate individual flights each day to get that done. And post-processing, that's just a lot more calibrations and a lot more trajectories to tie together, to where the helicopter, that's easy one flight. So it's easy for the collection side of things, but also the post-processing is, you're not dealing with all those different trajectories and having to calibrate each of those individually. It's all just one, complete data set that's there. So definitely a lot easier on the post-processing side of things to do that.
Yeah, so the Ranger XL, from a helicopter acquisition standpoint, it's safer, it's faster, it's more efficient, but also ends up being more streamlined on the post-processing end of things.
Yes, exactly.
Yeah. Let's get into your workflow. Can you summarize your typical workflow from mission planning to product delivery? I know that there's some people on here that use UAVs or do UAV-based LiDAR acquisition and all through to post-processing as well. And I bet they're interested in how that differs from, say, like a helicopter workflow.
Right. I've always thought when I first started doing the helicopter work with the same Phoenix LiDAR systems is, it's the same process, but you're essentially, you're kind of sitting in the drone, is like the way I like to think of it, where you're literally sitting there watching your LiDAR system instead of like having it be a little dot in the sky. So it's pretty cool in that respect, but the workflow is very similar. There's obviously different kind of nuances of when you're in a helicopter, but the overall acquisition, it's really the same fundamental steps, just a few kind of small tweaks here and there. But really the most important part for the acquisition is doing a good job pre-flight planning. And that really starts with the geospatial team looking at the project requirements and seeing what flight profiles we need to have, what flight line spacing we need to have to go out and have a good collection. So once the geospatial team does that, they'll really kind of work with myself, and we'll come up with some good flight lines on what's realistic for us to do as far as what the environment looks like, if it's mountainous terrain or airspace or anything like that. And then from there, we'll take that and we'll sit down and discuss with our pilot, really just kind of outline, what are we looking for as far as ground speed, AGL altitude and whatnot, and make sure we're on the same page as far as what the expectations of the acquisition are. And then for the actual acquisition, you know, kind of like I alluded to, you really need to make sure you have everything set up correctly for the acquisition. So it's very important to have the correct LiDAR settings inputted, because we do fly for, you know, 3 to 3.5 hours of collection. So if you're flying for 3 hours using the wrong scanner settings, essentially that data is useless, and you've burnt a lot of money and time for that collection. So the stakes are just a little bit higher, and you just need to really have your processes kind of refined to step up into something like this. And then from there, it's obviously a lot more data than what a UAV can collect in a typical day. So we're talking anywhere from 1 terabyte up to 2 terabytes of data that we're collecting each day. And it's important to make sure that you obviously keep that data. And I always keep a mirrored backup somewhere of that data until the geospatial team has it and upload it on our internal network. But the data processing, that's not my wheelhouse, but I kind of know the overall process. So really, we clean up, calibrate the point cloud, process the orthomosaic if the project requires it. And our typical data products are a calibrated, classified point cloud, orthomosaics, and then surface models like DTMs and contours. And as far as handing that off to our clients, it really varies on what our clients need, but we do anything from shipping off a hard drive to FTP links. We can do cloud storage and download. And then also we have a GIS viewing platform to where we can take this LiDAR data and any other data that we collect, like imagery, and have that put into one spot that's a easy kind of user interface to view the data and make use of it. Or we can do, help our customer essentially integrate that data into their GIS platform. So it's really whatever the customer wants, we're able to do.
Yeah, thank you for the overview on the project workflow. I think that's a good segue into challenges of helicopter acquisition. And can you detail out or shed some light on some of the challenges that you face when you're doing helicopter-based acquisition?
Yeah, the first thing that I noticed doing this type of work is just the large amounts of data, and kind of sitting there at the end of the day holding a small hard drive, knowing that there's thousands of dollars of data on this hard drive that it's very important you don't lose. So coming up with a good workflow of how you keep that data safe and how you always have a backup of it is a very important thing to have, and make sure that that data gets uploaded to the right place for the geospatial team. So really just coming up with that workflow and what does that process look like, especially when you have multiple sensor operators out operating in the field, of having those processes and procedures put in place is very important. And then also one of the struggles we've kind of had right away was collecting at the right height above the ground. In North Dakota, that's not very much an issue because it is just so flat that we can really just pick one altitude and stick at it and we're good to go. But like this picture here on the right, this is out in Wyoming, definitely more terrain variation. I think there was a couple thousand feet of terrain difference between the bottom and the top part of the survey area. So finding a good way to get an AGL altitude of while you're flying over was something that took a little bit of a learning curve and problem solving to figure out, but we're able to do that now utilizing a built-in radar altimeter, and then also ForeFlight does help with that a little bit. And then really just the logistics of the whole operation. So that's a big part of the pre-planning, is seeing where the project area is. How many flights is that going to take us? Do we need to go get fuel somewhere? Where's the closest jet fuel? And then also reference stations too. When we're able to fly, hundreds of miles at a time, we need to have reference stations kind of staged at the right spots to get good data for the post-processing team. So deciding if we need a ground crew assistant to go out and run those reference stations. So just the logistics are a little bit more complicated, but overall, it just takes some experience to kind of know what questions to ask and what to look for.
Absolutely. And like you were saying, like collecting LiDAR at the correct AGL above ground level height is absolutely critical, and maintaining that consistent AGL and staying also online within lane tolerances in X and Y is critical as well. And you've been using ForeFlight. Have there been any issues with ForeFlight or let's say features in Phoenix LiDAR Systems mission guidance that you're looking forward to trying out to maybe resolve some of those issues?
Yeah, ForeFlight, it works good for us. I would say the couple downsides to it is the pilot does have to kind of zoom in and out as he's flying. Let's say he's going on a corner and whatnot. So there is a little bit of interface the pilot has to do. And then also I would say just the AGL altitude. Now ForeFlight does give you an AGL altitude. However, their DTM or ground surface model that they use is a very low resolution and really not reliable. So that's kind of another feature that this mission planning software would help with. And then also knowing what your tolerances are and knowing what's coming up as far as terrain change is something that we're interested in trying out and seeing how that works for us in the field.
Yeah, with that heads up display, seeing if a hill's coming, if you need to start climbing in a couple hundred meters, something like that, if you're within lane tolerance, left and right, and also just having that ability to automatically zoom in so that the pilot doesn't need to take the hands off the controls. Yeah, I think that'll, I'm excited for you guys to try it and give us feedback on that. I think it's a good solution. So yeah, let's move on here to the value. So what are the most valuable data products derived from your Ranger series solutions? And I'll start this video going, and you can talk over it. You can dub over it.
Yeah, like I said, I think the electric utility space is really where this LiDAR system provides the most value, just because of that point density that we're collecting. You'll be able to see here shortly of just the resolution of data and the point cloud that we're able to get, but we're able to get a lot of conductor returns and static wire returns, all while getting a very good model of what the pole actually looks like. So not only, is the utility able to do vegetation management down to the centimeter of small branches, but they're also able to do conductor sag analysis, update their asset location, and any sort of engineering type work with that point cloud. So, while it is just one point cloud and data set, the quality and density of that allows for multiple uses of that one data set.
Yeah, such a rich data set, right? You can extract so much information from it, from vectors to raster models, all kinds of things.
Exactly. Yep.
And lastly, you mentioned the electrical utility industry, and that's kind of your bread and butter. I'm curious, what do you provide for, or how does the engineering industry and oil and gas industry use the data that you collect, and like what are they extracting? What valuable information are they extracting from LiDAR, and how do you help them in these industries?
Yeah, for the engineering side of things, that's where we really get into our wide area mapping projects, where we're mapping, tens to hundreds of square miles at one time. There's just a variety of use cases that the actual project is for, as far as watershed, any sort of like pre-construction or anything like that. We've also done a lot of survey work of state highways. So that's more of just a pre-construction, or if they want to reroute the road, we'll go and do a LiDAR survey of that. And then the oil and gas side of things, that is primarily pipeline right-of-ways. So we're able to provide quite a few data sets for the oil and gas industry, One of the cooler ones is being able to fly, the same pipeline, let's say twice or 4 times a year, and we're able to pull that data in and see how that ground has changed over time. And you can actually visualize that. So we're comparing those 4 point clouds, and whatever, ground has shifted within a couple centimeters, we're able to see that, and they're able to be more proactive on things with that. So, but yeah, the oil and gas, it's a lot of pipeline and some cool applications in there too.
And a lot of these oil and gas pipelines, they're just running underground. And if you're able to detect a change, let's say like 3-4 centimeters of ground change in elevation, then that would be like something of concern where they could go in and pinpoint that location and investigate it.
Yeah, exactly. Yep. The ground kind of moving on top over that pipeline, it can actually cause that pipeline to bend or break. So being able to see those small changes right away, like I said, just helps them be more proactive. And instead of like waiting until there's a major failure, they can get ahead of it and fix it before it becomes an issue.
Kind of nip it in the bud. Yeah. Well, thank you so much, Eric, for all of your insights. And I know that I see that we have a couple of questions here. Might be for you, might be for me. So I'll hand it off to Lido. And if any of you wrote questions, we'll try to get all of your questions answered here.
Yeah, thank you. We do just have a couple. Both of them are for Eric. First one says, I noticed in one photo, and I think it's one of the Bell, that you have the GNSS antenna on the front, but under the rotors. Does not having direct or continuous sky view impact the accuracy of the GNSS?
Yeah, that's a good thing to bring up. We actually did our first LiDAR project where we now have the GPS antenna on the vertical tail. And we did notice a difference between the data quality and the accuracy. While that antenna being under the rotor, and they call that rotor shadowing, where the rotors are actually causing small interruptions in the GPS signal. The data still turns out good, and we had great success with that. But we did notice a slight increase when we were able to get that antenna out from under those rotors. So good question.
All right, Eric, the next one is, you had mentioned that you could collect 1 to 2 terabytes of data in a single day of scanning. How is SkySkopes managing and storing that volume of data?
So it starts off on just removable hard drives. And then from there, we have internal storages and servers that all of our offices here are interconnected. And I'm not IT, so I might be explaining this poorly, but essentially we can upload something from our office here in Minneapolis, and then that'll be synced with our Fargo or geospatial team or whatnot. So it's all kind of stored internally here at SkySkopes.
And as a follow-up to that question, have you looked into cloud-based storage solutions?
Yes, we have looked into cloud-based storage solutions. We do utilize that. Some of our customers don't like to have their data on the cloud, but we do utilize that. And it just kind of depends on what the client wants and requires.
Okay, next question is one that we've heard a lot of. Do you have a threshold for acreage where you would deploy a helicopter as opposed to multi-rotor system? And has it changed at all with innovations in multi-rotor technology and increased flight times with multi-rotors?
Yeah, it'd be nice if there was a solid number to go off of, when do we deploy a drone team versus the helicopter. But it's too complicated to kind of put that into just a pure quantifiable number. There's just a lot of factors as far as what is the access like, what is the terrain like, is there high vegetation and whatnot. So we kind of found the sweet spot of where we do deploy a helicopter, but like I said, it just varies so much from project to project that it's hard to put an actual anchor amount to when we would deploy a helicopter versus a drone.
Yeah, well said.
And one last question I have here is, do you notice a difference in the data with dual GNSS antennas?
That's something that we're trying out right now. And really what we're trying to get to is the one flight pass. So instead of flying down and back on a corridor, and the dual GPS should help with that heading uncertainty. So we're just getting that set up right now on our 407, and should have a project here under our belt with the dual GNSS here within the next few weeks. So looking forward to seeing how that turns out.
Okay, and apparently there are a couple more questions that come in. One of them asks, someone is interested in knowing about the system that's attached to the hook area on the helicopter belly. Is that your XL or is that your LR?
Yep, on the belly mount of the 407, that is our Ranger XL.
Oh, okay, the XL. Okay, and let's see here. With the volume of data that you're collecting, do you make use of LiDAR mill or do you use a custom data processing pipeline?
So we started LiDAR collection before LiDAR mill. So we utilize other softwares to post-process all of our data other than LiDAR mill. So I don't think our geospatial teams ever used LiDAR mill before. Sorry, that's kind of all I know on that.
So do you create a point cloud in Spatial Explorer first and then export it to TerraSolid?
I believe so, yeah. I'm not very involved on that post-processing. Okay. So gotcha. Yeah, I'm not the right man to ask on it.
And we do have, okay, this could be the last question. Are you using, in fact, I don't even know what's on your system. Are you using a MEMS IMU or a FOG IMU on your high-end systems?
They're FOG, they're fiber optic IMUs.
Okay. And yeah, that's all the questions. Corey, anything else you want to sum up?
I just have one question, and then I think we can wrap it up. When you're following along a transmission line, and there are slight deviations and turns, like how often are you doing? Like, do you fly a straight line and then do like a teardrop and then enter another transmission line so you're completely straight, or are you turning during your flights? Does that make sense?
Yeah, no, that makes sense. That's something that we've kind of, I guess, refined on just flying more and more transmission lines and power lines. But a lot of it depends on what are the winds doing. But if it is, a 90-degree bend or 45-degree bend, we usually do a 270. So we'll just kind of fly through it and then do a 270 and come back around on it. If the turn is shallow enough of an angle, we're able to kind of keep the belly level and almost do like a pedal turn to turn and follow the power line. But a lot of that I leave up to our experienced pilots who are able to kind of understand what we're collecting and the swath angle, and they'll tell me if they can make that turn or they'll have to 270 it. So it varies on a lot of factors as well.
Okay, kind of a game time decision by the pilot.
Exactly. Yep.
Okay, I think that will oh, actually I do have one more comment. I did a quick lookup, and looks like on your Ranger XL you do have a IMU 32 FOG IMU on there for whoever was interested.
Thanks.
Okay. So I think that'll wrap it up for this April 2022 webinar. Thank you very much for joining. We will be posting a replay of this webinar on our YouTube channel, and also go to our news section of our website, phoenixlidar.com, for a link to it and for more information on our latest news. Also follow us on Facebook, YouTube, LinkedIn, Twitter, and Instagram, all of the social media. And if you have any questions, contact us at info@phoenixlidar.com. And I think that's it. So thank you very much for joining, and we will see you next month.
All right, thank you everyone, and especially thank you, Eric, for taking the time. That was very informative, so appreciate it.
Yeah, thanks a lot for having me. I appreciate it.